a really important topic in complex numbers is complex numbers. So what is the set of the complex numbers? We have x and y, which are real numbers, such that z equals x plus iy, and I is the square root of -1. So the complex numbers have some important properties. So complex numbers are closed under addition, closed under subtraction, closed under multiplication, closed under multiplication. And closed under division. So we are going to prove preliminary results. Let's assume that we have two complex numbers, z1 and z2. So z1 is a complex number, x1 and y1 are real numbers. And x2 and y2 are real numbers. Let's sum these two complex numbers together. So the real part is x1 plus x2 plus I, y1 plus y2. So this is the real part. Which is also, so we have the sum of two complex numbers, and we get back what? We get back a complex number. If we take the difference of the two complex numbers, what we have? We do some algebraic manipulations here. This is the real part of z1 minus z2 plus I, the imaginary part of z1 minus z2. So when we subtract two complex numbers, what we get back is a complex number. So here are closed under addition. Closed under subtraction. Now let's take the product of these two. So the real part is x1, x2 minus y1, y2, and the imaginary part is x1, y2 plus y1, x2. So this is the real part of z1, z2 plus I, the imaginary part, z1, z2. Close under multiplication. Now let's take 1 divided by z1. We do times the conjugate complex number, numerator and denominator, so it's x1 minus I y1 divided by x1 squared plus y1 squared. And this is x1 divided by x1 squared plus y1 squared minus I y1 divided by x1 squared plus y1 squared, which is a complex number. 1 divided by z2 1 over x2 plus I y2 equals 1. We take the multiply with a conjugate complex number, so x2 minus I y2 divided by x2 squared plus y2 squared. So it's x2 divided by x2 squared plus y2 squared minus I y2 divided by x squared plus y2 squared. So 1 divided by z1 is also a complex number, a reciprocal, and 1 divided by z2 is also a complex number. Now let's take the ratio z1 divided by z2. So it's x1 plus I y1 divided by x2 plus I y2. So we multiply with the conjugate complex number, which is x2 minus I y2, and the denominator is x2 squared plus y2 squared. So we have to take the real and the imaginary part, so it's x1, x2 minus I x1 y2 plus I y1 x2 plus y1 y2 divided by x2 squared plus y2 squared. So it's x1 x2 plus y1 y2 divided by x2 squared plus y2 squared plus I y1 x2 minus x1 y2 divided by x2 squared plus y2 squared. So I have the real part of z1 divided by z2 plus I times the imaginary part of z1 divided by z2, which means that this is also a complex number. Now let's take z2 divided by z1, so it's x2 plus I y2 divided by x1 plus I y1. We work things a little bit in the numerator and the denominator. So this is x1 squared in the denominator plus y1 squared. x2 x1 minus I x2 y1 plus I y2 x1 plus y1 y2 divided by x1 squared plus y1 squared. So it's x2 x1 plus y1 y2 divided by x1 squared plus y1 squared plus I y2 x1 minus x2 y1 divided by x1 squared plus y1 squared. So this is the real part of z2 divided by z1 plus I times the imaginary part of z2 divided by z1, which gives back a complex number